Pan beetle leaves. So we're going to start probability. In probability section, first we need to, because probability is a small topic, and there we are going to understand first how to write the contest related to probability. And I'm going to connect probability with permutation and combination related questions also. So one shot itself, probability will be able to understand many things. In grade 12, it will become very easy for you. So first understand what is the meaning of random experiment. So when you are doing any experiment where the outcome will be based on what experiment you are doing, that is exactly called as random experiment. So it is exactly going to be the experiment which will be coming as an operation, understood, and can produce some well-defined outcomes that will be considered as a random experiment. So when random experiment, we are going to talk about like one dice. Payoja, good morning, beta. Sorry, good evening, Payoja. I'm going to teach. I'm started. I've started beta this what you call probability and probability topic. After that, limits. I'm going to start. Okay, so it's a very important topic. No, 3D, one part is there. Most probably the questions are over. Only there, one question session will be there. Yes, in 3D part, the question session will be coming that I'll be teaching. Okay, so now let's go for the work. Okay, yeah, 3D one section is over. Only one last section is there that I'm going to teach with probability. If you wish, I will first finish that and will to do that. But most of the questions in 3D is over, beta. Okay, so now look here. I'll be just going to the work what we have started with. Now come on, check this one out. Hmm. Shall I start my work? Now let's look into this part. What and all we have to do. Just I'm checking all are there. Rudra, good evening, beta. So now listen. Some experiments, because probability is that topic you need to remember very nicely and you need to understand very nicely probability topic, beta. So understand in probability the first word is called as random experiment. Nishika, that fan you switch off. So first experiment, first word is called as random experiment. Understood or not? So here random one experiment will be deterministic experiment. Understood? What is the meaning of deterministic experiment? Where you have to वायर के साथ जो लटके हो ना तुम पंदरिया, थोड़ा दूर रहो वायर वायर से. So one section will be called as deterministic. Deterministic means कि there you have to like bring that result. Understood or not? But random is not exactly the one where you can have to bring only that result also. So like in a lab when you are standing and you know that your count, your value what you are bringing for the answer, it has to come same most of the time, then that will become little bit deterministic. Understand? You have to determine it and you have to find it very close to Every experiment you have to bring the answer very close to each other. That comes as a deterministic part. But random is not like that. Random or probabilistic approach will not be like that. Here what you are going to do, I took a dice and the dice I am going to throw, the dice can give me any one of the 6 possible outcomes. So that comes random part it is coming. Are you understanding? So it is giving a probability experiment. So tomorrow is going to rain or not, I can say it may rain tomorrow. Understood? It's a random part. I said randomly. I am not determining that. But if tomorrow is a cyclone and I'm going to say that tomorrow it will rain, that means it becomes a deterministic. Did you understand what is the basic difference between deterministic and random? I hope you might have understood. Deterministic means when you are exactly knowing, hey, why you people are deleting everything? So when you people are exactly when you are knowing that what is random, what is deterministic, I hope this content you might have understood this part. Is it okay for you people to understand this part? What is random, what is deterministic? Okay, very good. Gagan, good evening, beta. Good evening, Rudra, Payoja. Now listen. Next part, sample space. Beta, what is the meaning of sample space? Sample space meaning is total. Divya, good evening, beta. Sample space means given total outcome you are writing for an experiment, that becomes the sample space. Like beta, you have a dice, and the dice you are exactly rolling. So when you are rolling a dice, so when you are rolling a dice, what can be the possible outcome for rolling a dice? The possible outcome for rolling a dice is 1, 2, 3, 4, 5, and 6. And beta cardinality means it is number of elements present in sample space. So number of element present in sample space is coming as 6. I hope you might have understood. So that comes under calculation part. So sample space is the total element and the number is coming as like this. So this is called as sample space. So if somebody will ask you what is the meaning of sample space, then what answer you are going to say? Sample space is the total observation of a specific experiment. So it is coming as the total. So definitely total means whatever random experiment you are doing, the all content should be present there. Like in a set, when you are writing universal set, it is consisting of all the element. Same here, sample space means the one which will be consisting of all the elements inside it will come under sample space. I hope you might have understood. Now what is called as elementary event? Understood? So I hope sample space you understood. Sample space. Understood. So when we are writing, when we are tossing one coin, so what can be the sample space of tossing one coin? So tossing one coin, sample space will come either head or a tail. Understood. So two outcomes are possible. Welcome, Divya. When we are tossing two coins together, then that time the sample space will become head, 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 tail, tail, head, and tail, tail. So this is exactly the total outcomes when you are absolutely correct, Gagan. That is absolutely correct. So H, head, 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 tail, head, and tail. So that are the all possible outcomes when you are finding two coins together tossing. But if somebody will ask you, if you toss 20 coins together, then what is the total sample space? Now say, one coin tossing together is giving you two sample space. Element, how many elements are coming here? One coin is giving you two. Absolutely. More outcomes. No, you have to give exact answer there. So here, how many is given? Two coins together will give you four. So that means if one coin is there, absolutely 20 outcomes, no. Rudra is absolutely correct. Beta, if 20 coins are there, say 2 to the power 1, 2 is fixed here because a coin is having how many faces? What the permutation says, that fixed part is head and tail. Fixed part of the coin is head and tail. Absolutely correct, Siddharth. So 2 to the power 20, that's the correct answer. So 2 to the power, so if a coin is having two sides, that means 2 is fixed. So here 2 coins means 2 to the power 2. 10 coins means 2 to the power 10. 20 coins means 2 to the power 20, and that is equal to 1048. Understood. 1048576. Thank you, Siddharth. So this is exactly the answer. So this is called as total sample space, and total sample space is always coming as NS. Probability is going to be the most dangerous topic for you for exams, competitive exams also, and for 12th also. So now itself, please kindly do it very particularly. I hope you might have understood this one, beta. So now, yes, the correct answer is 2 to the power 20. Now we will go for the next part. So now when we are going for elementary event, you know what is called as elementary event? Elementary event. So elementary event, if somebody will be asking you what is the meaning of elementary event, if a random experiment is performed and one outcome, known outcome you want, it will become elementary event. Understood? So elementary event is coming like that. So if I want one, so one game you are playing, Ludo or chess or whatever you are playing, at that time, beta, what you are exactly going to do is you will throw the dice and you are expecting what 1 to 6 is there, you are expecting 1. Understood? So what is your elementary, your outcome is 1 out of 6, one outcome out of 6, expectation is 1. Now beta, sample space already I have discussed. Now we will be solving one exercise of NCRT is totally based on this sample space, because if you will align a sample space, you will align the events also. The event will come from sample space. Beta, what you have studied in class 10th, 11th, in the beginning sets chapter, so whatever universal element will be there, so universal set will be there like 1 2 3 4. So a set will get contain elements from there only. Understood? So B is equal to 2 3. That means 100% whatever element you are getting, you are exactly getting from universal set only. So here also from the sample space elementary events will be coming. So whatever event will be coming for probability, it will always come from sample space. So what is the formula for probability? Probability formula will come as, so probability of an event will be equal to number of element in the event by total sample space. This is the formula. Understood? So this is the formula for probability. How many event you expected, that event by total event. This is just like universal. How many elements are there in the universal set? Now probability of any event values is always coming from between 0 to 1. This will become impossible. At the case when the case is not at all possible, that time it will become impossible event. Impossible event outcome is always 0, and possible or sure event outcome will always be coming as 1. This is impossible event and this is sure event. The probability values always lies between 0 to 1. Understood? So probability answer can never be 2, or probability answer can never be 1.3. Probability answer can never be negative. Understood? Because their value lies between 0 to 1. The fraction should never exceed 1. It should always come between 0 to 1. This is one very important part. The probability answer will be negative. No, all these three are not possible. Understood? So the value lies always between 0 to 1. Now one more important, yeah, 0.6 is possible. Now beta, probability of occurrence of an event plus probability of non-occurrence of an event is equal to 1. This is one thing we have always known. Means not possible plus possible is equal to 1. This is one of the formula. Now beta, we are going to learn some of the questions related to writing the sample space. Now we will start the sample space part, beta. Just get the first question. In the first question, what you are going to do is, in a class of 3 girls are there in the class, and these 3 girls are going to dance with 2 teachers of the classroom. So what in all be the total sample space where one girl can dance with one teacher? What is the possibility when one girl can dance with one teacher? So two female teacher and three girls are there in a class, and they are going to organize a dance program for any function, understood, for a school annual day. So how the preparation, the total sample space will come as how? The total sample space will be coming as girl 1 can dance with teacher 1, girl 1 can dance with teacher 2 also. So now girl 2 can dance with teacher 1, girl 2 can dance with teacher 2. Now girl 3 can dance with teacher 1 and girl 3 can dance with teacher 2. So this is the total outcome beta. This is the total sample space. Understood? Because you have to find interaction between one girl and one teacher. So this is a way of writing the sample space. Now how many elements are present, Himanshu? So this is called as sample space, Himanshu. The condition was three girls are there in a class and two teachers are there. They have to participate in a program and one girl can dance with one teacher. So what and all possibilities there? Girl 1 can dance with teacher 1 or teacher 2, girl 2 can dance with teacher 1 or teacher 2, girl 3 can dance with teacher 1 and teacher 2. So 100% the total sample space is coming as 6. I hope you might have understood this one, beta. So this is a way of writing the sample space. My next question is, come on, you people are going to tell me the numbers. Okay. So Gagan answer is okay. Now beta, we are going to understand this next part where you are going to write the number from a group of write this question nicely, from a group of two boys and three girls, two children are selected. How many children are selected? Two children are selected. Find the sample space. Find sample space. What can be the possible sample space? 6, I guess. Okay, Siddharth, let's check this one out, beta. Now we are going to write it, Siddharth, but there is one problem, Siddharth. If you check that part, everyone please see how many boys are there, beta. Two boys are there and three girls are there. Two boys are there and three girls are there. So 1 and 2 and three girls are there. But here one very dangerous thing given, that they are telling two children are selected. They did not said here one very important thing is missing here. Children, I think you people are missing one very important thing. They did not told one boy, one girl. They did not told like that. They did not ever one time they have said like that. So first, maybe in the sample space, two boys can be selected together. Understood. Two boys can be selected together. Now boy 1 can be selected with any one of the three girls. By boy 1, boy 2. Understood. Now boy 2 can be selected with any one of the three girls. Now girl 1 can be selected with girl 2. Girl 1 can be selected with girl 3. Girl 2 can be selected with girl 3. Did you understood here? So this is the problem, beta. In the statement was not clear to that one where it is exactly understandable. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a total 10 possibilities are there. Understood. So here 10 possibilities are there. So total element in the sample space will be coming here as 10 beta. So this is definitely a very tricky part. Yes, Siddharth, correct. Gagan, correct. Everyone is correct here. So like this only we can write beta. When they will not specify now, that time boys can also match with boys, girls can also, because two children are selected and children is away from gender. Understood. Children word is away from gender. Children is a common word used for both boys and girls. I hope you might have understood. And this is NCRT question what I have solved right now. Another NCRT question I am giving you, children. Are you ready for it? So this is a way to write beta. Next NCRT question we are going to do. Question is, a coin is tossed. A coin is tossed. That means beta, a coin will have what? One head and one tail will be there. Hello Avni. One coin is tossed beta. So once the coin is tossed, it shows head. So after tossing, it is showing what beta? It is showing head. So if it shows head, understood, we draw a ball from a bag. After it is showing head, then we are going to draw, we draws a ball from a bag. Oh my god. So once it is showing head beta, once it is showing head, after that only we are going to draw a ball from the bag. After that only we are going to take out a ball from the bag. And how many colors balls are there? 3 red color balls are there. After that beta, 4 black color balls are there. After that, understood. But if it shows tails, understood, but if by luck it is coming tails, then we throw a dice, understood, then we have to throw a dice. Got it? So total sample space will be what? Total sample space for this situation, total sample space for such situation will be, what can be the total sample space for such situation? Come on, come on, come on, get me the point please. First head is coming, then how you are going to write the sample space? If head is coming, that means how many in the bag, how many red balls are there? 3 red balls, R1, R2, R3. How many black balls are there? 1, 2, 3, 4 black balls. Understood? So here one by one randomly you are going to take out. So beta, what will be? It will be either first red ball will be there, then here second red ball will be there, then third red ball can be possible, then black ball can be possible. This is comma I am putting, okay. So here what is there? It is going to be head with second black ball, head with third black ball, and head with fourth black ball beta. So this is what. So with the head, how many black balls possible? 4 black balls. With head, how many red balls are possible? 3 red balls possible beta. And what is the total number? But if it is coming tail, tail means dice will have how many outcomes? 1, 2, 3, 4, 5, 6. They told that if it shows tails, we throw a dice. If it is showing head, then you have to take a ball out of this. So 1, 2, 3 red, head with red 1, head with red 2. What are the total possibilities? Anyone can come out now. Any one of the 7 balls, 3 plus 4, 7 balls can come out. So head with any one of the 7 balls will come out. Tail with any one of the 6 dice can be coming out. I hope till here everyone understood this part. So beta, what is the total sample space? 7 plus 6. What is the total sample space coming here beta? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So total it is coming as 13. I hope absolutely correct beta. Correct Gagan. So this is a way of writing the answer. Now I'm giving you another opportunity to write an answer. Ready everyone? Yes, Siddharth, Divya, absolutely correct, beta. So this is exactly the correct answer. The answer will be coming as 13. Now, beta, another question we are going to write. Now, write down the next experiment because sample space means MCQ questions and they will be asking you which category, what and all things are there. It's so hard to type. Yes, I can understand because event is coming, beta. In that event part is coming. And from NCRT, some content questions are there, which is little bit tricky. So we need to draw that, understand this. Once you will understand this section, beta, it will be easy for you. Huh? So now we are going to go for the next one. Question is, an experiment consists of rolling a dice. Okay. So you are going to roll a dice, beta. An experiment. Understood. So an experiment is consisting of rolling a dice and then tossing a coin. First dice you have to roll and then coin you have to toss. Understood. Tossing a coin once, if the number on the dice if the number on the die is even. Okay. If the number on the die is odd, means if the number on the die is coming as odd, the coin is tossed twice. Nishika, do it. The coin is tossed twice, Peter. Understood. So, what is the sample space? Come on, tell me. What is the sample space here? So, what can be the sample space here, beta? Wow, super. This time Siddharth did not took time. He has given the answer. 18 is the answer. Let's check this one out, beta. An experiment consists of rolling a dice and tossing a coin once if the number on the dice is even. Okay, number of a dice is even. Check na, correct only na. With 2, what can come, beta? With 2, either head will come or tail will come. First, we will talk about even. With 2, either one head will come or one tail will come. Cut it. With 4, either one head will come, one tail will come. With 6, either one head will come, one tail will come. Got it? But if it is going to be an odd number, then 2 times you have to toss. So if it is 1, then it will be coming as head head. It all possibilities will come. One with head tail, one with tail head, one with tail tail. So this is exactly possibility, one with head tail and one with tail tail. So this is exactly 1, 2, 3, 4. With 1, 4 possibilities is coming. Then with 3 also same scenario will be there. Head head. Now with 3 beta, head tail. With 3 tail, head will be there, and with 3 tail will be there. With 5 also same scenario, head head, head head, and tail. So total how much it is coming, beta? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the sample space, well done Siddharth, answer is exactly coming as 18. Understood? So yes, it is coming as 18. Check one time. You are absolutely correct, Siddharth. Yes, you are absolutely correct. With odd number 4 times, 3, 1, 3, 5. 1, 3, 5. With this 4, 4, 4. 4 ones are 4, 2 z, 4 3 z, 12. Here it is coming. And 2, 4, 6, 2, 2 times. 2, 2, 2. 14, 16, 18. Absolutely correct, Siddharth. Nice. Super. Yes, answer is absolutely correct. Understood or not? So this is exactly the correct answer. Now we are going to go for one question which is exactly going to go for another level question. So if somebody will be talking to you like this and they will be telling you, find this answer, yes, Siddharth, but this question, one question I am going to give you, this question you need to solve. Question is, this is an NCRT question. Now, beta, this question try to solve. They're telling that a die is thrown. Got it? Repeatedly, means many times. Okay. So repeatedly a die is thrown. Repeated. R-E-P-A-T-E-D-L-Y. Spelling is gone. Repeat. R-E-P-E-T-A-P-E-A-T-E-D-L-Y. Repeatedly. Understood. So many times it is exactly, many times it is thrown until a 6 comes. Until a 6 comes. Okay. What is the sample space for this experiment? What can be the sample space for this experiment, Beta? Now try this question out. No, Siddharth. No, this is not that answer. Repeatedly, Beta, repeatedly, Siddharth. Repeatedly it is coming. Now you need to answer this question. You need to understand this part. Come on, think about it. Repeatedly answer is coming. Repeatedly this answer is coming. Hmm. Now, Beta, can I do it? Infinite, absolutely correct, Siddharth. Now, beta, one time, see, understand, one time you tossed a dice, throw a dice, and 6 came. You will stop, correct? But another time, you are tossing, it can come one, and then next dice 6 came, stop. 2, 6 came, stop. 3, 6 came, stop. Understood? So if 6 is coming means you have to stop there only. Got it? Now here 1 came, again you tossed, 1 came, next time 6 came, stop. Then 1 came, 2 came, 6 came, stop. Now next time 1 came, 1 came, 1 came, 1 came, and then 6 came, stop. Then 1 came, 2 came, 4 came, 5 came, then 6 came, stop. That means what? It can be going to that, but till 6 limits will be coming, it will be exactly. Understood? So how many tries you will do? Till that many tries, 6 has to come. The moment 6 is coming, yeah, this is exactly going to stop. The moment you are getting a 6 miss, it is going to stop. So this is exactly the part. Now, beta, we are going to talk about events. Understood? Yes, so 6 coming na beta, once 6 is coming means you have to stop. So if first time itself 6 is coming means you won. Now next time you threw the dice, 1 came. Then public is telling you draw another time, 6 will come. So the second time you did, 6 came. You stop. Now third time you did, 4 5 times you did, then 6 came. That 4 5 times should be included in your experiment now. So 6 is coming means you have to stop. So it, that type of situations once coming, it can go to infinite series. Understood or not? Now, beta, I'm going to start probability. In that probability sections, event. So a specific outcome is considered as event. Understood? So event can be of different type, but first we have to understand what is the meaning of some words which we are going to use in probability. Got it? First is when somebody will write not A. then that means a to the power bar. We have to first understand the language, not a. Understand or not? So a to the power bar means it is not included. It is not included. Not included. Now, if somebody will say, I will take either a or b, is it lagging? Understood? Not lagging? Okay. It is either A or B, means A or B. A or B means in probability, you need to tag both. So it will come A union B. Understood? A or B here means A union B. It's a simple, straightforward content. It is coming as A union B. A or B is nothing but A union B. Understood? A union B. But if somebody will say A and B, at that time common you have to find, that is coming as A intersection B. Means different event can give you different possibilities, different answer. But next time A but not B. That means you have to include A, but you can't include B. Then you have to write B bar. Understood? Now, neither A nor B. So if you are writing neither A nor B, that means it will be A bar intersection B bar. So both should not be included. That is considered as neither A nor B. Got it? So now at least one of A, B, C, at least one of A, B, C. So if somebody will be asking you, yes, A intersection B complement, A intersection beta, it will become A complement, intersection B complement will become A union B complement. This is De Morgan's law, and A complement union B complement will become A intersection B complement. Please kindly note down this too. In shortcut, we are going to use this one beta. That's correct only. So A intersection B complement, no beta. This will become A union B complement. This has to be checked one time. This has to be checked one time. So at least if somebody will say at least one of A, B or C, that means A union B union C. But why at least is going with A union B union C? You must remember this one. A union B union C means, see, if I say that at least I can eat one chapati, that means I can eat many chapatis. Understood? I can eat total entire how much is there. So definitely it will become A union B union C. At least means start with minimal, go to as max as possible. So that comes under A union B union C. Exactly one of A, B and C. Understood? Exactly one of A, B and C. So if somebody will say exactly one of A, B and C means when one will be there, second will not be there. Understood beta? Exactly one of A, B and C means what? If A will be there, then B and C will not be there. Union, A will not be there, B will be there, C will not be there. Understood? Union, A will not be there, B will not be there, C will be there. This is the meaning of exactly one of A, B or C. And every time whenever you will be doing exactly one of A, B or C, at that particular moment, beta, you need to write only one which is working, two should not be working. Understood? And their union you have to find. So this is called as exactly one of A, B or C. Got it? Now exactly two of. Exactly two means at that time here exactly two of A, B and C means at that time two will be there, one will not be there. So here this will not be there. So exactly two means any two will be there, third one will not be there. So this is called as exactly two of A, B or C. Here exactly one of A, B and C. At least means everything must be there. And when they will use the word all, when they will use the word all of the above sets, that means all must means common of all the three. It is coming as common of all the three, beta. This is neither of A or B means A union B intersection. That will come as neither. And this is exactly called as De Morgan's law, beta. This is coming as De Morgan's law. The entire probability pillar till 12th class is based on this one, and permutation combination content also is one part of it, which is exactly applicable to these sections. Understood? So we will be applying that section also. Now, I'm going to start some word problems. Absolutely. Gagan understood na beta. So we will be doing Nishika written. Everything must be written there. So now look here. So now we are going for the second part. In the second section, if three non-empty sets are there, A, B and C. I'm starting the preliminaries. Probability part writing also I will teach you how to write. But beta, if three are there, three, then first you have to find only, first part, only A occurs. They are using the word only A should occur. Only A should occur means B or C should not occur. So only A occur. At the time when you are writing only A occur, how you are going to write? This is one part. At the time when they will be saying only A occur, what you are going to write? Got it? After that they are telling both A and B occurs, but C does not occur. Got it? But C does not occur. You need to write the situation. 2 and no more occur. First three we will do. First one. Now, beta, how it is very simple. Only A occur. In your set, what and all three things are there? You have A also, B also, and C also. And all the three are there. And all the three are going to participate in all the events. Understood? So here, only A occurs. So first answer is A is occurring, but B and C is not occurring. So A will occur, but B and C is not a part of it. Absolutely correct, Siddharth. This is the first answer is absolutely correct. Bless you, beta. Second part check to everyone. Okay, I'm giving time for children because they're typing and typing will take time. So let's see. Second one answer, beta. Try this one out. Very good, Siddharth. This is also absolutely correct. Here they are telling both and A and B occur, but C does not occur. That means A is occurring, B is occurring, but C is not occurring. Absolutely correct. This is very nice. Now 2 and no more occurs. Try this. 2 and no more occurs. Means maximum 2 will occur, but no more than that occur. Now how we are going to answer this question? Intersection. How to type? N. N also possible. Kuti N. Hmm. Absolute correct. This is correct only. Like A and B can occur, but C cannot occur. A and B can occur, C cannot occur, union. B cannot occur, but A and C can occur. A cannot occur, but B and C can occur. Absolutely correct. Super beta. Yes, Gagan Siddharth. Seriously, you people dared to type it. Nice beta. Thank you so much. This is exactly the toppest one. Nice. You both are absolutely correct. This is the way to write. So now what is the meaning of sure event beta? Sure event outcomes will be maximum one. Understood? So whenever somebody will be telling that certain experiments will be there, when the experiment will be performing and you are getting a perfect outcome, it will become a certain or a sure event. Understood? Impossible event means when the outcome will be phi, outcome will be considered as phi, it will be coming as an impossible event. Understood? So if somebody will be telling you that I am throwing a dice, what is the possibility of getting a 7? 100% is it possible? It's an impossible event. Right? I told I'm going to throw a dice and I want 7 in the dice. Is it possible? No. So that's surely going to be an impossible event. Now, it is going to be an impossible event. I hope you might have understood there. So these are the different type of mutually exclusive event and exhaustive event. I'm going to explain what is the meaning of mutually exclusive event. Okay. Now understand what is the meaning of mutually exclusive event. So when the mutually exclusive event is coming, like sample space is having 1, 2, 3, 4, 5, 6. Now A is having odd number set 1, 2, 3. B is having, sorry, 1, 3, 5. And B is having 2, 4, 6. So what is A intersection B? Is there anything common here? Is there anything? Okay. Is there anything common here? The answer is coming as here 5. Here nothing is common there. Here nothing is common. So beta, when some things like this situations will be coming, then how it is called as exclusive, mutually exclusive event. How we are going to write it as mutually exclusive event. Now, beta, probability writing part is we write, see, probability can be written as probability of A union B is equal to probability of finding set A plus probability of finding set B minus P of A intersection B. Then how we wrote probability? Probability is event. This is event by sample space NS, event by sample space ns plus event by sample space ns minus event by sample space ns. Did you understood beta how to write the probability sections? Correct now? So whenever you write event, the upper part will become event, a specific event A union B by total sample space. A union A by sample space. But beta here nothing common is there. So how to write? Now check this one out. How to write this? So when you are writing A union B, A union B becoming the sample space itself now. So here it will come all the elements, 6 elements will come. So here what you are going to write? N of A union B. So A union B, total A union B will be coming as what here? It will come 1, 2, 3, 4, 5, 6. Correct now? So here it is coming, once you are solving this part, it will come 6 on 6. Correct? Now it is mutually exhaustive. Mutually exclusive. Exclusive means intersection part is not there. Now beta here A is coming 3 by 6. Now you check B is coming 3 by 6 and this is 0. Is LHS equal to RHS? You 6, 3, 3 1 by 2 and plus 1 by 2. It is coming as 1. So LHS is equal to RHS. So what is the meaning of mutually exclusive? At the case when mutually exclusive event will be there, then the probabilistic approach will have only P of A plus P of B, its P of A intersection B will always be phi empty. This is the case of mutually exclusive event. Children, did you understood till here? This is a case of what beta? This is a case of mutually exclusive event. Understood. It is a case of mutually exclusive event. So it is coming as 1 by 2 plus 1 by 2. It is coming as 1. So left side is equal to right side. It is coming as 1. I hope you might have understood till here. Mutually exclusive means null event. No, intersection will become null there. Intersection will become null there. That's the most important part. Intersection is going to be null. Uh, this is equal to be 0 beta. This is equal to be 5. Which part I wrote? This is minus 0 because intersection part is coming as 0 beta. 0 by 6 means 0. There you wrote not equal to 0. Intersection part. Intersection is coming as 0. I wrote here 6 by 6. It is coming 1. Oh, this LHS is equal to RHS. This is a case of box P of A union B is equal to P of A plus P of B. But beta intersection part will not be there. Intersection section will not be there. That means P of A will be there and P of B will be there beta. But intersection section part is coming as not there. So union will be there, intersection part will not be there at the case of mutually exclusive event. At the time of mutually exclusive event beta, intersection part will not be there. This is what I wanted to say. Let's check, did I wrote any box there? This will be beta P of A union B will be there, P of A will be there, P of B will be there. But A intersection B will not be there. Okay. A intersection B will not be there, beta. This is a case of, okay, that is a case of what, beta? This is a case of exclusive section. I hope you might have understood this one. Now this is case exhaustive event. Now our next word is exhaustive event, because next class we'll start solving question and I will connect probability with some extra probability section also I will teach, so that you will be able to understand 12th probability easily. Next part is exhaustive event. Now, what is the meaning of exhaustive event, beta? Exhaustive event like this only. Exhaustive event means just now, na, our A was what, beta? 1, 3, 5. And what is our B? Our B was 2, 4, 6. So, if we will find A union B, it is giving us S. So, this is called as exhaustive event. So where we will find the union of everything. So like A1 union, A2 union, A3 union, A4 is total coming as S. It is considered as exhaustive event. Understood? What is the meaning of exhaustive event? If all set events together will make the sample space it will be considered as exhaustive event. I hope you might have understood, beta, what is the meaning of exhaustive event. So we did important event, mutually exclusive event also we finished. After mutually exclusive event, exhaustive event also we have finished. Yes, yes, beta. I have explained everything. Yes, some extra part in probability also I am going to teach, because board examination 12th 11th means some compile some different sections of probability also I am going to teach. So I am going to keep it till here, beta. I hope the class might have been interesting for you. You could have understood it nicely. Yes, good night. Good night, beta. But the difference between the two is, now listen, that's a very good question, Siddharth. What is the difference between the two is, see, here you are finding union of the situations, union of the event, and if all the different event given to you, it will become S. After adding all the event which is exactly given to you, you are finding S, then you will say that it is exhaustive. Understood? That time, beta, you are going to say it as exhaustive. But mutually exclusive means, see, mutually exclusive can be exhaustive. It is possible. Mutually exclusive can be exhaustive. Yeah, this part is given in NCRT. Mutually exclusive is given as exhaustive, beta. Exhaustive can also be mutually exclusive. So look here. In the previous question itself, na Siddharth, A was having 135 and B was having 24, beta, 246. No connection was there. But when we added together, it gave the sample space. Correct now? So here, yes, so that's what. So mutually exclusive can be exhaustive. Exhaustive can be mutually exclusive. But here one is for intersection, where intersection of two events is coming as 5. But here the union of all the events given together is given you sample space. Then it will be called as exclusive. I hope you might have understood the difference between the two, beta. Okay. Bye everyone. Good night.